This video is brought to you by Sporlan, quality, integrity, and tradition.
All right, last weekend I had a service technician that was on call, and he got a service call that an exhaust fan wasn't working. It was actually Friday afternoon. So we rushed out here because they couldn't cook, and what we found was that this exhaust fan right here had a bad motor. The technician, the motor was locked up, it was burnt, it was all, fried inside the motor. So the technician went, picked up a new motor, came back out, installed the motor, and when he installed it, he went to go check power and realized that they didn't have three-phase power. So we found the reason why the motor went bad. They had lost three-phase power. He did a little troubleshooting. I don't have footage of this, but what actually happened was right here in this junction box, down below the roof deck, a wire burnt for some reason. They lost one of the three-phase wires. So the motor was single phasing and it burnt up the motor. Well, because it was below the roof deck, there really wasn't much we could do. So we told them to call an electrician. They called an electrician out. On Saturday morning, the electrician came out, pulled new wire to the panel, and my technician came back out Saturday evening, hooked up the motor the rest of the way because we left it unhooked because we didn't want anybody to be responsible for powering it wrong or anything. So we made sure we had the right power, powered it up, exhaust fan was working. But then my technician went downstairs into the electrical room where the motor starters are, because why didn't the motor starter trip, right? What happened here? So he went into the motor starter panel and found some really weird stuff, of which I'm here to correct now, okay? So this guy, I came out once, everything was working on it, everything was fine, but I also went into the electrical room and my technician was correct. Wait till I get down there, but you'll see the electrician, I don't know, who knows, some weird stuff happened. So let's get down there and see what happened. All right, so we come into here, and if I remember right, yeah, this is the one. So this is a motor starter. This is here to protect the motor. It has a contactor coil built into it. When they turn the 115 volt power switch on at the hood system, this pulls in. But if there's a problem with the motor, overloads will open and the motor will stop working. Okay, the theory is that this is supposed to protect the motor before it burns up. It's advanced protection essentially. Now this is a really old system, but it's much more advanced protection than just say a circuit breaker that just looks at the current, right? This looks at the current a little more precise essentially, okay? Now of course there's more precise than something like this too. But electrician pulled new wiring. First and foremost, this green ground wire identifies as blue. This white wire identifies as red, I guess, right here. And this black wire doesn't want to go through the overload, so it goes to the other side of the overload. Now, why the electrician did this, I don't know. Maybe, just maybe, it was a Saturday, maybe he didn't have the right color wires. And, functionally, a green ground wire still functions the same as a black or a red wire, okay? But the idea that it's green, indicates to some people that that is going to earth, to ground, okay? You want to do a better job of taping that if you're going to tape it. This is kind of a half-assed job of taping it. This right here is amazing. Just a piece of red packing tape. Like, look, it identifies as red. That's lovely. Okay, so I'm going to go ahead and replace this motor starter. I don't know why the overload was bypassed like that. Okay, I have no idea, but I'm going to go ahead and start over. We're going to put a new motor starter in there, and we're going to do our best. I'm not going to pull new wire because the electrician already did the work, but I'm going to go ahead and properly tape this up so that way it's more the right colors, kind of a thing. So let's get into this. Started by shutting off all the breakers for the exhaust fans, disconnecting everything. And then we're just going to slowly unhook everything. Now I capped my control voltage because I did turn control voltage back on, so that way they have lights in the building and the hoods and stuff. So I just capped it off for now, and then I'll turn it off when it's time to hook the control voltage back up. But we're just going to disassemble everything, get a new motor starter put in, and then wire, or set it and everything. I've got my new motor starter assembled, which just basically means a contactor and an overload relay, and it's all about how you wire them so that way it disconnects the load if there's ever a problem. So we'll wire that up. It's a 120 volt coil on this guy, and then the overload range is 2.5 to 4 amps. So what we're going to do then is get in here. We got to mount this on the back wall. This unit, you can screw this in if you want, but I prefer the DIN rail mount. So I'm going to mount the DIN rail back here, and then we'll clip this guy on, and it'll be super easy to service. The little details separate you. Throw a level in there, get the DIN rail level, then the starter sits level. You know what I mean, Vern? I did my best. It's polishing a turd, but I taped up the lines, made sure that they're, you know, the right color and everything. Now these units, I have the control voltage back on. These units are always shipped in a tripped position, okay? And right here is where we set our overload. We do not have high voltage on at the moment. So for now, I'm gonna go ahead and set my overload high, and then we'll dial it in once we go up onto the roof and figure out where we exact setting needs to be. So we just hit reset, now it's pulled in. Okay, so the way that I have it wired is the common neutral wires coming into 95, and then coming out of 96 is going up through here and into the coil, right? And then you have 120 volts coming into A1. Okay, this is the way that it's set up. That way if it trips, it stops the motor starter because it opens a circuit right here and then it stays open. So now we can go ahead and turn on the high voltage and go make sure that I got the rotation correct. I mentioned that we needed to check the phase rotation. This motor is spinning counterclockwise, okay? It's hard for you guys to see. It may look like it's spinning clockwise, but it's not. And the rotation indicator down here says this guy should be spinning counterclockwise. So our motor rotation is correct. Now let's head downstairs to set the overcurrent protection. All right, so we have our motor nameplate right here, and our motor nameplate says that at 208 volts, which is what we're running on our circuit, we are allowed to run 2.54 amps with a service factor of 1, okay? So I used to size these whatever the current was times 10%. And technically, you should be sizing off of the service factor. So with a service factor of 1, we're going to take the 2.54 times 115%, and then we're going to find our current value. So when we take that math, we come up with an overcurrent setting of 2.92, all right? And then if we look in here, right on here is our overload. So basically, we need to set it right at 2.92, which we're just going to go right there, okay? So that's our overcurrent protection right there. We are currently running 2.15 amps, so we should be good to go. And just to confirm, let's verify that we actually are delivering voltage. So we are under the 208 volts at 203 volts, so we're good to go. So we should be protected on this motor now. It's a little bit cleaner in here. I've definitely got some trash to clean up and everything. And I'm interested in that guy. I'm going to look into that guy a little bit too, because I don't know if they have an overload that's bad on it. I know for a fact that the technician that was out here over the weekend measured voltage coming out of those overloads. And we had 3-phase voltage going up to the roof, but we did not have 3-phase at the motor. And he found the problem to be at that junction box and below the roof deck. So that's why the electrician had to get here. So when my technician came back to start it up and he saw that that overload was bypassed right here, he was like, what the heck? And that's when he told me about it. So we let it run, but I came back today and went ahead and dialed this in and finished it up. So we're good to go on this one. This heater right here was bad, so that's why it was bypassed. And I don't know what happened with that, though. That's what I'm confused by. I don't know when that went bad. But regardless, we went ahead and changed the motor starter. You can see that these are just a fusible element, essentially. Let me pull this one out. It's just a fusible element. When the current gets so high, the metal melts. This starter also wasn't wired correctly. They basically weren't set up to disconnect in an overcurrent situation because this thing was disconnected. I don't know what was going on here. But regardless, instead of trying to play with things on an old unit like this, an old starter, I'm not going to try to rebuild this. This thing's beat up. It's all burnt inside. It's just easier, faster, quicker, and cheaper to go ahead and replace it with a new motor starter like I did. It's back up and operational, set for the current setting, for the proper current setting, and everything is good.
Motor starter systems for exhaust fans and smoke detectors or duct detectors for air conditioners. Those are two of the things that I constantly find not wired correctly or not set up correctly. In this situation, this is an older system. I'm without the customer's permission, I'm not going to reinvent the wheel with their entire hood system, okay? But I can tell you that that hood system could use a refresh, right? All the motor starters should be rewired, set up properly. I can guarantee you that they're not, right? I didn't go through it, but I can just pretty much guarantee you that. I do a lot of work with motor starters and hood control systems. I'm actually in the process, and I'm going to try to film this one, but I'm actually in the process of bypassing a smart hood system right now where it had smart hood controls, and it's this whole thing. So if I can get good footage on it, stay tuned. I'll show you guys the whole process of going through it and bringing it into compliance. But regardless, in this situation, honestly, okay, I'm going to tell you guys something. I don't like to talk crap on people, okay? But the particular electrician that did the work at this job, they are the same electrician that I've had a lot of issues with. They are a huge company that works in Southern California, and they work in a lot of restaurants, and I've had a lot of issues with them, okay? I have a video a while back where a disconnect switch was totally ruined because the electricians, they wired it. It was just nuts. It was the same company, okay? It is what it is. You know, it's not my duty to get involved with the customer. The customer, they know that there's issues because I constantly have to come behind them and fix things. So they know on a corporate level, they know too. I don't know why. It kind of baffles me as to why they still continue to use them, but that's not my thing. Okay. I'm just here to make sure my equipment's operating properly. This is part of the reason why I do not let them start up my motor. Okay. I had my technician leave our motor completely out of the picture. That way, when the electrician did it all, then I could go back in and make sure everything was correct. And hence we found some issues. Okay. When I see those three wires, the green, black, and white, I kid you not, I wouldn't be surprised if they wired this for like 115 volts. And I wouldn't be surprised if, you know, I don't know. I have no idea what they were doing. But regardless, I came back in. I changed the motor starter. I don't know why that overload was bypassed because it wasn't bad before. I'm 100% sure it was not bad before. So I don't know. This is why I have serious trust issues, okay? I do not leave stuff set up for other people to wire it and start it up because good gosh, the stuff that could happen. So we always come back in and try to make sure everything was done correctly when we have to have another vendor come in and help us, okay? So in this situation, I went back in, I sized a new contactor and overload, which together made a motor starter, which essentially has overload protection. And I kind of missed a key point in the video. When I was explaining that a motor starter is more of a precise control of the motor, it's not so much that. It's just that a breaker is meant to protect your wiring, okay? It's meant to make sure that your wiring doesn't melt. And a motor starter is there to simply protect the three-phase motor or the single-phase motor, so be it if you want, okay? It's there to protect the motor. You set the current, just a little bit over the service factor, depending on what the service factor is. And another thing that I want to say too, you always want to read the motor manual, the manual that comes with the motor, or reach out to the manufacturer to find out how they want you to set motor protection, okay? In this situation, I confirmed via documents on the internet that this particular motor had a service factor of 1. We should set it at 1.15% or 115%, and that's what we set it at. That service factor means that the motor can run at that higher current value for a limited amount of time. You never want to have a motor operating within the service factor all the time. It's only there for short periods of time, okay? And you always want to lean on the motor manufacturer to find out where you should set your overload protection for your motors. Just don't trust some guy on YouTube. Do your research yourself too, okay? So we got the motor starter sized correctly, installed correctly, wired correctly, and I cleaned up the wiring as best as possible. Now the bummer is that beyond that motor starter box right there, you have green, white, and black wire running all the way to the roof. That's kind of a bummer, but you know, that's why you never trust just the color of a wire to indicate anything. You always verify, check voltage, make sure that it's actually what you think it is. Don't assume, because assuming will get you killed. Seriously. Okay, no joke. I've seen some crazy stuff out there, so don't assume. I've told this story many times, but you know, before I understood what was going on, the first time I ever worked on a corner grounded delta, right? I was at an old industrial area. It had a shopping mall, and I was checking voltage to something because it wasn't working right, and I was checking voltage to ground on a three-phase system. It was a 230-volt three-phase system, and one leg to ground had 0 volts, but across all the legs, I had three-phase 230 volts, and that scared the crap out of me because if you go in there and assume you know, that you just don't have power and you don't know what's going on, that's a corner ground or corner grounded delta system. That'll get you. Okay. You get electrocuted by that if you don't know what you're doing. So don't ever assume, always be, you know, research and figure it out. I encourage you guys to Google a corner grounded delta system. It'll blow your mind the way that they work. It's really interesting. And it's kind of scary that when my butt puckered when I checked voltage, because I was checking voltage, and then three phase. And it was like, wait, what the heck? And I remember calling an electrician buddy of mine. And he's like, wow, where are you at? And then he explained it to me, but it's a whole crazy thing. So anyways, I digress. As usual, I go off on rants, right? I really do appreciate you guys making it to the end of the video. Hopefully you guys get something from this. Thank you so very much. Remember, if you're interested in supporting the channel, a couple different methods. The easiest way is simply watch the videos from beginning to end. That really is the easiest way. You can support the channel by purchasing tools through TrueTech Tools. Go to TrueTechTools.com, find something you like, use my offer code BIGPICTURE. You get an 8% discount on majority of the items on their website. There's a few things it doesn't apply to, but when you do use that offer code Big Picture, again, one word, I get a small commission from that, so that's a great way. You can support the channel via PayPal, Patreon, YouTube channel memberships. There's links in the show notes. Oftentimes on the YouTube channel memberships, unfortunately, I can't do it for PayPal or Patreon, but on the YouTube channel memberships, because of the way that YouTube does things, I have it set up. If I get these videos done in time, I usually release them early to the channel subscribers on YouTube channel memberships. So sometimes they get them early. That's just one cool perk. You can also support the channel via my website, HVACRvideos.com. We have merchandise available, hats, beanies, sweatshirts, hoodies, stickers, all that good stuff. So check it out. Again, I think that's everything that I need to say. Thank you so very much for making it to the end of the video, and we will catch you on the next one, okay?